Okay, so let's continue. Researchers are interested, not just researchers, in answering many types of questions. One is a scientist might want to know whether the Earth is warming up. Okay, so a physician might want to know whether a new medication will lower a person's blood pressure. That's very important. An educator, of course, is interested to see whether a new teaching technique is better than the traditional one, and so on and so forth. So these types of questions can be addressed through hypothesis testing, okay, which is a decision-making process for evaluating claims about the population. Remember that population is not always people. So the three methods used to test hypotheses are the following. One, the traditional method. Second is the p-value method. And the last is the confidence interval method, which I will not discuss here. But the idea is still the same with one and two. So confidence interval, if the test value is within the range, you cannot reject the null hypothesis. If outside the range, then you can reject the hypothesis. It's the same idea with the method one and method two. Okay. So what are the steps in hypothesis testing? The traditional way. So first, before that, let's have some definition of terms. Every hypothesis testing situation begins with a statement of a hypothesis. There are two types of statistical hypothesis. One is the null hypothesis and the alternative hypothesis. By the way, when we say hypothesis, specifically statistical hypothesis, it is a conjecture. When we say conjecture, it is a claim that is assumed to be true or untrue. It's just a claim. It needs to be tested. So the null hypothesis, symbolized by H naught, is a statistical hypothesis that states that there is no difference between a parameter and a specific value, or that there is no difference between two parameters. Okay, so the type of hypothesis testing that we're gonna include here is hypothesis testing about a population. So we have a population, we sample, this is the sample, so we are comparing the sample and the population. That's why it's stated here that the null hypothesis can also be a statement that there is no difference not only between a population and the sample, but also two populations or two parameters. Okay, but we're not gonna discuss that type of hypothesis testing. The other type of hypothesis testing is known as the alternative hypothesis. It is symbolized by H1 or sometimes HA, and it states that the existence of a difference between a parameter and a specific value or uh, between parameters. Okay, so it is a statement that claims that there is a difference between a sample and a population or between two population or two parameters. So, for example, situation A, we have a medical researcher is interested in finding out whether a new medication will have any undesirable side effects. That is very important. The researcher is particularly interested or concerned with the pulse rate of the patients who take medication. So that's the measurement. Will the pulse rate increase, decrease, or remain unchanged after a patient takes the medication? Since, okay, this is very important, the researcher knows that the mean pulse rate for the population under study is 82 beats per minute, so that's the prior knowledge. Okay, we have to believe that that is true. Okay, that the null hypothesis or the mean pulse rate for the population is 82 beats per minute. So the hypotheses are one, h naught, mu is equals to 82, and h sub 1 is that mean is not equals to 82. Okay, you're not sure if it is greater than 82 or less than 82. So if you're not sure, your alternative hypothesis should be negative. The null hypothesis specifies that the mean will remain unchanged. Okay, meaning even after you took the drug, the null hypothesis will neither increase nor decrease, and the alternative hypothesis states otherwise. This test is called two-tailed test, remember that, a term that will be formally defined later, since the possible side effects of the medication could be to raise or lower the pulse rate. Yeah, but actually, if you're a researcher, it just means that you don't know the effect, whether it will increase or decrease. So if you want to be safer, if you want to be conservative, you have to use the two-tailed test. Okay, that can be used for exploratory research. Okay, or you don't have enough data or information to predict the effect of something, so you have to use the not equal. Another situation where you have more information or you are informed. The chemist invents an additive to increase the life of an automobile battery. If the mean life of the automobile battery without the additive is 36 months, then her hypotheses are the following. H naught is equals to 36, I mean the mean, and the H1, the mean of the battery, will be greater than 36. In this situation, the chemist is interested only in increasing the lifetime of the batteries, of course, no? Why would you do a research in this regard that you're not interested in increasing the lifetime of the batteries? Uh, so that would make sense only. So her alternative hypothesis is that the mean is greater than 36. It should be greater than 36 now, because the chemist has been working to increase the lifetime of the battery. So that's the basic idea of the research here, I suppose. Another hypothesis is that the mean is equal to 36. That is an assumed truth or based on the information previous. This test is called right tail since the interest is an increase only. So yes, it's right tail because, as you can see, the direction is to the right. Okay, last situation, situation C. A contractor wishes to lower heating bills, right, by using a special type of insulation in houses. If the average of the monthly heating bills is $78, her hypothesis about heating cost with the use of insulation are the following. Number one, the null is that it's still the same. Of course, it's always the status quo or the same numbers that we know of. And since she wants to lower that cost, then uh, her interest is in this direction, which is left tail. Okay, so basically we have three types: two-tailed, right-tailed, and left-tailed. To state hypothesis correctly, researchers must translate the conjecture or claim from words into mathematical symbols. So it's just uh, easy. Two-tailed test equal, not equal, right-tailed test equal, greater than, left-tailed test equal, and less than. And these are just examples, some of the common phrases that are used to describe whether the claims or hypothesis is two-tailed or right-tailed. Okay, like is equal to, is the same, is shorter than, is longer than, is has increased, and so on. Okay, so in this book, the null hypothesis is always stated using the equal sign. This is done because in most professional journals and when we test the null hypothesis, the assumption is that the mean, proportion, or standard deviation is equal to a given specific value. Also, when a researcher conducts a study, he or she is generally looking for an evidence to support a claim. Therefore, the claim should be stated as an alternative hypothesis, meaning you are trying to support the claim against the established claim, that is the null hypothesis. So that is why alternative hypothesis is also called research hypothesis. So HA is sometimes also called research hypothesis because the researcher is trying to prove that the alternative hypothesis is true compared to the null hypothesis. Okay, so let's continue. Okay, so for example, state the null and alternative hypothesis for each conjecture. Letter A. A researcher thinks that if the expectant mothers use vitamin pills, the birth weight of the babies will increase. the average birth weight of the population is 8.6 pounds. Letter B. An engineer hypothesizes that the mean number of defects can be decreased in a manufacturing process of compact discs by using robots instead of humans for certain tasks. The mean number of defective discs per 1,000 is 18. And the last letter C. A psychologist feels that playing soft music during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, the mean of the scores was 73. So if you're going to write the null hypothesis and the alternative hypothesis, you should be basing them on the key words. So for letter A, it's clear that the alternative hypothesis uh, is to the right. This is the null hypothesis, 8.6. For letter B, the number of defects can be decreased, meaning it is to the left. It is left-tailed. And the null hypothesis is that it is 18 per 1,000. And the last, a psychologist is unsure. So it's not sure whether the effect of playing soft music will positively or negatively impact the grades of or the score. So the mean or the null is 73, and this is two-tailed. So when you write hypothesis, they should be in these forms. Then a hypothesis, colon, the mean, the alternative hypothesis, H sub 1 or HA, colon, and then the right alternative hypothesis or mathematical statement. Okay, so that's how you write hypothesis.